Hey everybody, this is Larry. This is day 11 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Why is my computer slow? Validate binary search tree. So given the root of a binary tree, determine whether a valid binary search tree, if it is a binary search tree. Okay, so the left subtree contains, so basically the idea here is checking, perhaps recursively, and that's very often what you do with a tree, at least, the way that they structure these, is that every node on the left is less than or equal to the current node on the root. They're not unique, right? I didn't really see anything about uniqueness. That's what I was looking for. And everything to the right is greater, right? And in this case, it doesn't have to be balanced, so we can't just do that. Yeah, let me think about how what is the clean way of doing it. But yeah, I mean, I think there's a couple of ways you can do it, but the way that I am going to do it is just maybe just like getting the min, given a node. So we have a helper function. We go, maybe get node or something like this. I don't know. Naming things are hard. One of the hardest problem in computer science. And then here we want what does this function do? We want to get the smallest smallest number in this node. This is gonna be so yucky. Some smallest number in this subtree, and the largest number in this subtree at the same time, right? So then here, if node is none, then we would just return something like, yeah. I guess we don't get to it. Yeah. I guess we don't do it that way. I think it's fine. We could check for leaves maybe. So if node dot left is none and node dot right is none, then we return the leaf, which is node dot value, right? And then otherwise we go left is equal to get node of node dot left, right is equal to get node of node dot right. Oops. And then now we want to check whether so left, maybe we could use a name tuple. Let's actually try to do that. I forgot the syntax though. Name tuple of let me look up the syntax for a second. I need to practice this a little bit more. I think that's the story. But okay, so yeah, maybe min max is equal to name tuple of min max, and then you have the attribute which is min and max. So then we can do something like, yeah. And then now left dot max, we just want to make sure that this number is less than or equal to node dot value is less than or equal to right dot min, right? So if this is not true, then we return. I guess maybe we want to return validated or something. I don't know, because we use a global value because we only need to do this once. So how do we want to do it? All right, maybe valid. So then here this is true for now. So if this is not the case, or left dot valid, or if this is not valid, or if right is not valid, then we return I guess we can just do valid is equal to this, right? And then we can now return min max of valid min of left dot min, because you're trying to get the smallest number, node dot value, right dot min. Though technically, it doesn't really matter if this is not valid, but I'm just kind of doing it in a funky way, maybe. And yeah, and that's pretty much it. And then we run it for the root, and yeah, so always go this, return or dot valid, maybe something like that, and let's give it a spin. Huh? Did I miss? Maybe I misread this one. Oh, whoops. Yeah, obviously my valid is upside down because we want, because this is returning the case where if this is not valid, right? Why did I do this? So valid is you go this and not and okay. Okay, why is that? Dong dong dong. Oh, actually, this is very funky because I definitely have like there's a thing where it is going to be recursive. Oh man, I'm a little bit off today. Because you have 2, 1, 3. Okay, that comes up, and then 4. Nope. So this should run into infinite loop because I don't have a case for the 3 going left. Yeah, or maybe just none. But so that's weird. Okay. So yeah, if node is none, then what do we return? Well, we return maybe just negative infinity, and let's just say it's true because if there's no node, then it should be okay. Infinity is just some big number. Node is none. Oops, of course. Okay, so at least it runs, but now it's returning. Everything is returning false. So okay. Oh, whoops. Why did I write not? I think I kept not from earlier on, but of course it has to be that both left and right is valid, right? Okay, so at least this should be a little bit more accurate. Yeah. Why is this wrong though? Which is the 1, 2, 3, 4 tree, right? So the 4 node, the 4 should be, yeah, the 4 should be here, and then the 3 node. Oh, the 3 node has this as the max. I think when I got it backwards a little bit, because I think this should be, yeah. Okay. Whoops. A lot of silly mistakes, but the idea is just recursion. Man, I'm not smooth lately, to be frank. Am I good? Can I submit? Let's give a submit. Apparently I've gotten wrong answer before, and today I'm not feeling super confident. I actually thought we talked about the uniqueness, and I've forgotten about it, to be frank. A little bit under the weather, but why did I return true? I mean, this is kind of silly because I feel like, yes, by this definition is true, but like it is what they say. But for a regular binary search tree, I think decode is supposed to be good, right? And I wasn't sure about it. I guess maybe I should have tested the case, but you know, like it is a like that's the thing with redefining things, right? And I think, and that's maybe I'm wrong. I think yeah, so okay, so that was kind of silly. But because I think a regular binary search tree is supposed to have, like, if you handle a duplicate thing, that is the way to do it. Yeah. So I feel like that's a little bit weird. I know that's strictly by the definition they give us, but binary search tree does have another definition, right? So I think that's just a little bit weird. Let me look it up. Maybe I'm wrong though. That'll be funny. I'm just searching binary search tree uniqueness. I don't know, but either way, that's really awkward. But I mean, I feel like I don't feel as bad about that one. What did I do last time? Okay, same issue, I guess. I don't feel as bad about this one just because that's I don't know. That's just like an awkward thing. Like that's such a gotcha. Because I was looking for uniqueness, but I just didn't know how to resolve it. And I guess on an interview, of course, you should, and I would communicate a lot just as I've been coding. I'll be like, oh, I think about unique values. What do I do with the unique values? And then hopefully they will tell me the answer. Like about tell me the answer whether how to treat uniqueness, right? And once they tell you, it's easy to set it up. It's just about understanding the problem. So I don't feel that bad about it. So this one is going to be linear time, linear space, or O of H space if you want to go that well, where H is the height of the tree, and linear time because we just look at each node once. There is a regular tree traversal. In my case, I guess technically it's a pre-order or maybe post-order, depending on how you want to. Maybe this is part of the processing, but I mean that part is not that important either way, because so yeah, so it's a tree traversal. It's gonna be linear time, linear space. Like I said, O of H as well as the tree space. Okay, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.